So here at McKinley today, what we thought we'd show you is how we do our automatic uncoupling on our shunters. So what gear do we need to do this? Well, first we're going to use Bachmann's 08 Shunter. It's DCC ready, and obviously we need a chip, and we're going to use an ESU Lock Pilot 8-pin chip. Obviously it's not a lock sound chip, it's a Lock Pilot, so we don't need sound. And from Précis models, what we've got is two coreless motors, and these are to drive the KD couplings so they open on command. So let's unbox this model, whip the shell off. Even though we're changing the front coupling for this uncoupler, we need to take off the back coupling to get access to the screw. So you whip the screw off, which is under the NEM socket. Before you lift the body shell off, there's a little pipe at the front left hand side that needs to be removed. And once that's off, we're away. So keeping your workspace clear, we need to get off the 8-pin chip, which allows it to run on DC, so we have access for our DCC 8-pin chip. The next thing we need to do is remove the paint from this metal boss at the front, and this is to enable us to glue a resistor on top of the boss, which will allow the heat to sink away from the resistor into the metal boss, and there you can see the shiny surface. So removing one of the resistors from the pack, what you need to do is just shorten the legs and then super glue it to that boss on the chassis. Whoops. We got there in the end. A little bit of super glue activator will soon seal that in place. Mangama was the make of super glue. To tin the legs of the resistor is the next thing, and hopefully you can see the blobs of solder. So whip it upside down, pop it into a Pico foam cradle, and we need to remove the front coupling and the NEM socket that goes with it. And underneath on these Bachmann models there's a screw to release, and then you can remove the air tanks. The close-up shows you these air tanks, but to allow access for the coreless motor to be fitted, we need to remove some of this area just next to the NEM socket. So using a little razor saw is to remove the material. And in next to no time. you're done. And there you can see how much we've removed. So pop the loco back into its cradle and then refit the air tank assembly that we've just modified. But first, remove one of the tanks, and this will allow access for the draw cotton to open the KD coupling. And then pop the screw back to hold it in place. Now we need to manufacture a small piece of metal, such as from a Coke can. It's 5mm wide by 15mm long, and it serves as a bridge to go across the bottom of the loco to hold in the coreless motor and the coupling on the NEM socket. It'll be held in by the screw underneath, so you need to put a little dot on this piece of metal so you'll know where to drill the hole. With a 2mm drill, just pop a hole in your little bit of tin that you've fabricated, and there we are. Next we need to drill a small hole using a 1mm drill, which allows the wires from the coreless motor to pass through up to the DCC chip. There's not much material to remove. You can see daylight through the crack before we started. And there we are, quite straightforward. And then the cables from the coreless motors, thread those through the hole that you've just drilled. Lay the coreless motor into the little gap, just for us to do a test fit. And then undoing that screw, we can use that screw then to hold the plate in place. And there we are with our test fits complete. All seems to fit okay. Moving on to the couplings now. This is a size 20 KD. And we need to thread the cotton through the knuckle of the coupling. It's all in the instructions and it is quite straightforward, and hopefully if you have any Boy Scout training, I'm sure it'll come in handy here. And there you can see the jaws opening. Next thing to do, loosen off the screw that's holding the metal. And next, with a little bit of black tack, pull the coreless motor out of the way and then pop it underneath where the coreless motor goes. Oops. Black tack's similar to blue tack, it's just tackier and a little more permanent. And there we are. Next, assemble the coupling. Pop that into place. And there's the cotton opening the jaws of the coupling. And once more back to your Boy Scout knowledge, it's time to thread the other piece of the cotton around the spindle on the coreless motor. And a drop of super glue will hold that all in place. And the activator speeds up the super glue's drying time. Quick test. Lovely. It's a little bit fiddly, but to have a game-changing shunter like this must be a great asset to any shunting layout. So on goes the piece of metal again, with a little curve on the downside, as it were, and that will hold the coreless motor and the NEM coupling in place. Also snipped off the KD trip pin underneath the knuckle because that's no longer required. Now the cables that came up from the coreless motors, we've trimmed them a bit. And solder one end of the red cable from the spare piece. And obviously the other end of the red goes on the other end of the resistor. And make sure you just tuck out the excess out of the way. Clearly we don't have enough hands to do soldering, so using a little bit of black tack is plug the 8-pin decoder into the black tack to hold it steady, and then you can solder the other two cables on. Obviously a small solder tip helps here. And the black cable goes to the blue and the red cable goes to the green. Good wire strippers are essential here. The last thing you want to do is try doing this with a modelling knife. So as I said, it's the black onto the blue and the red onto the green. So time to reassemble. So make sure the cables are all clear from the 8-pin socket. So whip off the black tack. And then plug the 8-pin plug back in, but obviously make sure it's the right way around. Try and tuck the excess cable out of the way the best you can, and then it's time to do something with the DCC chip. So another bit of black tack onto the front or the back of the 8-pin socket, and then taking the slack out of the cables to the chip, and then secure the chip then onto the back of the 8-pin socket plug. The body shell will invariably be a little bit tighter now because of the chip and the black tack at the front. But it all should fit back together, just a little bit more snug than last time. And hopefully you haven't lost the screw from the rear. And then secure the body shell. So there we go, all done. Just need to take it upstairs and test it.
So Pete has put the chip and the little tiny uncoupling motors in the engine. The next step we have to do is to program that shunter to behave as we want it to run the uncouplers. Here at McKinley, we standardized on one particular manufacturer's range of chips, and that is the ESU Lock Pilot and Lock Sound version 4 and upwards. The reason we've standardized on one particular chip manufacturer is so that we don't make mistakes and that we only have to learn one set of parameters. We found that these chips are nowadays, they're so complicated, or a lot of them are. There are lots of easy ones, I should stress, but certainly some of the clever chips, they're so complicated that to learn 2 or 3 different manufacturers is a pain. So we've standardised on ESU. Because we've standardised on that, we've also purchased a specific high-speed programming device called the Lot Programmer, and it comes with some software that's on this PC. That allows us to save profiles of engines and to be able to master the things we need to change very easily on screen through a dedicated application. Let me show you here how we program this engine. So I've got the open file screen. I'm about to open the profile that we specifically created for our shunters. I'm selecting it here and I'm opening it, and I'll take you through the specific settings that we have for this locomotive. The first thing we would do is set the address, which is 818, and it's a long address on this locomotive. The uncoupling settings are in a section here called function settings, and there are 3 CVs that you change. The first one is the speed of the engine movement, the second one is the push time, and the third one is the pull time. And that is simply all you do for setting the uncoupling chipset, sort of turning it on, so to speak. You do, however, have to do one additional component, and you have to tell it which function key you do. In this Lot Program application, that's on this screen here, and if you see down here, we've scrubbed into here, we've said that F9, which is the standard for McKinley for uncoupling locomotives, will fire off the uncoupling sequence. This one is done for both ends, and I could take that off for this engine, but that's neither here nor there. And what I will do is I will now write that data to the decoder, and I'm going to override all the defaults, and it programs that chip, and it's a relatively fast process. It's now programmed the chip, and what I can do is go straight to testing mode. What I'm going to do is put a little brake van on the end of it and couple it up. And what I'm going to do is take it forward just a moment, and then I'm going to press the uncouple button, function key 9, and it should push the brake van backwards, uncouple and pull away from it. There we are. How beautiful was that? Thank you, Pete. So there you see how simple it is, and these little uncouplers are quite transformative for us on the railway here. All of our locomotives, whether they have those little uncoupler motors or not, do the little uncouple shuffle on the F9 key. And we've got that in place for all of our mainline engines if we've got fixed magnets at the end of platforms and at the ends or the arrival areas, so that those engines can uncouple from their trains and move on. But having the ability for a shunting engine to uncouple at any location in a yard is transformative for the operators. It's a bit like the change from DC analog world to DCC digital world, where you're driving the engine and you're operationally enjoying yourself. You're doing what a shunter would have done in real life.